Hey everyone, hello and welcome to today's webinar. We're going to get started here in just one moment. I'm going to allow about 30 seconds for folks who are running late to arrive. So if you'll bear with us, we're just about to get started. We're really excited to have you all here, and thanks for your patience. Looking forward to kicking things off. Okay, let's go ahead and get started. So hello and welcome to today's webinar, Drones in Marine and Offshore, Improving Safety and Reducing the Costs of Inspection. We have two expert speakers presenting today from Bureau Veritas. We're really excited to hear from them. They have a lot of experience using drones in marine and offshore settings. So we're really excited to draw from all that experience and share their knowledge with everyone who's on. Before we get started, we always feel like it's important to acknowledge that we are living in difficult times. We know that people are struggling and suffering throughout the world right now with the ongoing global pandemic. We just feel like it's important to acknowledge that fact. I also want to say for folks who are joining from the US, happy Independence Day, a day or two early. Thanks for joining us. We know that for some of us, it's already a holiday, so we're glad to have you here. For everyone else, we're also glad to have you here. Thanks for taking the time to be with us today. So before we get started, there's just a few items that I have to share. The first is to introduce everyone. So I'm your moderator. My name is Zach Dukowitz. I'm the content marketing manager at Flyability. Today we also have with us from Bureau Veritas, Vincent Joly. He's the digital solutions manager at Bureau Veritas. He's been there for almost 2 decades. Damien Thierry is also joining us today. He's the offshore network support and new technologies manager, and Damien's been with Bureau Veritas Marine and Offshore for 8 years. So we have almost 3 decades of experience that we're drawing from in the presentations that we're getting today. A few sort of housekeeping items before we hand things over to Vincent and Damien. The first is that we encourage everyone who's on to ask questions. Unfortunately, given the webinar format, we can't have everyone jump in and ask questions verbally, right? We'd love to do that, but it would just be chaotic if we had 200 people with live microphones jumping in. But the next best thing is to have you type your questions in, and feel free to do that at any point during the webinar. We do have about half of the webinar, about 30 minutes devoted to a Q&A at the end, where you'll get every question that you have answered by Damien and Vincent. But that doesn't mean that you need to wait until the Q&A period to ask your question. So please feel free to jump in, type your questions in at any point. We have a team of people working behind the scenes, curating your questions, saving them, and we'll be making sure they all get answered by the end. Another common question that we get that we just want to answer up front, if you're wondering whether you'll get a recording of the webinar, the answer is yes. We will be sending out a recording. You can look for that in your inbox within the next 24 hours. There's a slight delay just because GoToWebinar needs time to process the video. As soon as the video is processed, we'll have it live and we'll send it out to you. So the last thing I'm going to cover before I introduce Vincent and Damien is today's agenda. We start with an introduction. That's what we're doing right now. Then Vincent and Damien will present together for 20 minutes on the topic for today, drones in marine and offshore, improving safety and reducing the cost of inspections. And then the second half of the webinar, 35 minutes approximately, will be devoted to a panel discussion and a Q&A where we can really draw from all of Damien and Vincent's experiences and really learn from them and get all of our questions answered again. So once again, please don't be shy to chime in and ask questions. And just in case, the place to ask questions, if you look in your dashboard, there is a questions pane. and you can pull that open just by clicking on it. If you happen to type a question into the chat pane, that's fine too. We'll see it there, and we'll make sure that that gets answered as well. Okay, so I'm really excited to introduce our two speakers today. Vincent Joly, as I mentioned, has been with Bureau Veritas for a very long time. He's the Digital Solutions Manager at Bureau Veritas. He's worked in Bureau Veritas Marine and Offshore for 17 years. In that time, he's held several different positions throughout the world in places like France, China, and Korea, where he's helped oversee surveys onboard ships and offshore units. Since 2018, Vincent has led digital transformation programs at Bureau Veritas, leading the effort for the organization's digital classification strategy, which is aimed at leveraging different digital technologies to transform its classification operating model. In that role, Vincent's helped implement the use of drones for remote surveys in confined spaces on several types of ships, including LNG carriers, VLCC, and ferries. And he's conducted tests of drones and other technology to confirm that they meet Bureau Veritas's operational needs for the inspection of a ship's structure. In addition to Vincent, we also have Damien Thierry here today. Damien is the Offshore Network Support and New Technologies Manager at Bureau Veritas. In the Bureau Veritas Marine and Offshore division, I should say. He's worked in that division for 8 years. Damien began his work at Bureau Veritas as a technical advisor with a focus on extending the longevity of floating offshore units. After 5 years in that role, he moved on to become an offshore structural engineer and project manager, where he oversaw the design review of offshore units, oil tankers, gas carriers, and renewable energy projects. At the beginning of this year, Damien was put in charge of support and development for new technologies for offshore applications from an operational point of view, which include the use of drones for marine inspections. So between the two of them, Damien and Vincent have a lot of experience with drones in inspections in marine and offshore applications. So we're really excited to hear from them. Without further ado, I'm going to hand things over to Vincent, who will be leading the presentation today. Give me just one moment. Okay, Vincent, you are live.
Thank you, Zach, for the introduction. Good afternoon, everybody. Good morning for those joining from the Americas. So let me introducing shortly the activity from Bureau Veritas. So we are the world leader in testing, inspection, and certification services. So you can see that we have a lot of markets from the industry, from the agri-food, commodities, buildings, and infrastructures, also for system certification, such as ISO 9000, also certifying consumer goods, many things. But today, we will talk about the marine and offshore market. So what is Bureau Veritas Marine and Offshore? So mainly, Bureau Veritas Marine and Offshore is a classification societies. What is the activity of a class? It means verifying the conformity of ships that are either under construction or in service in accordance with all Bureau Veritas classification rules and IMO conventions that mainly concern structural soundness, reliability of machinery on board. So our clients are shipyards, shipbuilders, ship owners, equipment manufacturers, oil majors, EPCI, insurance company, P&I club, lawyers. We are conducting design review, survey at yard, certification of materials and equipment at manufactory, and we are indeed for ships and offshore units in service, conducting periodical and occasional surveys. So our fleet today is more than 11,000 units. We have almost 200 survey stations all around the world, and we are 2,600 employees working for the Marine and Offshore. Totally, Bureau Veritas group is 78,000 employees. Today, we are talking about the inspection by drones, and I would like to present you our objective. So I have to remind that classifying ships, inspecting ships is a very old activity that is already almost 200 years old. And this was done till now by traditional techniques, such as using scaffoldings, stagings, also using rafts inside the ballast tanks, by divers, by rope access companies. So you can see that means of access are mainly based on human. And this is a dangerous environment because we have to enter into confined spaces. We have to work at high. And so back, what is our objective today? Our objective is replacing these costly and dangerous means of access by safer and more efficient remote inspection techniques for inspection of the hull. So here you can see examples of these remote inspection techniques: drones, poles, crawlers, ROVs, cameras, but we will focus today on the use of aerial drones. Why aerial drones? First of all, because it is providing safety. Our surveyor, when we are conducting an inspection by drone, don't have to enter into the tanks, into the confined spaces. They also don't have to work at high, so it's really a safety improvement for human lives. Also, it's a time saving because it is reducing the preparation of the confined spaces. You know, usually before entering into those spaces, these have to be ventilated thoroughly. We have to run gas detection, many things. So the procedure is quite significant before entering into the space for the inspection. It reduces the preparation on board. It's also a time saving when executing the inspection itself, because the drone goes faster than human inside the structure. And it's also enable a better planning, better anticipation of the repair before the dry docks, so better anticipation of the immobilization of the ship. All this indeed result into cost saving, but we believe that the biggest opportunity to save cost here is thanks to the drone. We have a much better anticipation of and appreciation of what will be the repair. So we can, let's say, pay for scaffolding only for the minimum necessary that will remain the repairs. It's also a reduction of cost because it is lowering the deployment of all these means of access. Then we do see also an opportunity of improving the quality records, and here improving the maintenance on the hull condition of the ships, because those technologies, and especially aerial drones, provide a complete record of the hull condition during the survey. Traditionally, you know, the surveyors, they are going into the tank, the structure, but they are not taking so much picture on making a mapping like this. But drones can. And thanks to all the videos and pictures generated by the drone, it's also an opportunity for data-driven services, a new approach of condition monitoring that will also enable potentially a future predictive maintenance of the ships. Today, this is already a reality for some offshore units, and we do believe that it will become the future trend for ships as well. Last but not the least, it's also an opportunity to generate a 3D model during the inspection, which is an opportunity for better quality record, better planning, and better maintenance of the asset. I will let the floor to Damien, who will give business on the technical focus presentation on our use cases.
Thank you, Vincent. Hello, everyone. As Vincent mentioned, there are numerous benefits to use drone to perform inspection. We have recently performed different tests, POC and pilots, in order to define how best to exploit its potential. So, what is our use case for air drone? So, let me reverse the definition of our use case. If you have a look on the last point of this slide, we have focused our effort on the ship with large volumes and limited means of access. Here, it is easy to get all the benefit to use drones. Indeed, the drone will be able to reach high area and faster than a surveyor without installing specific means of access, such as scaffolding, rope access, and so on. So we focus our attention mainly on what we call ESP ships, such as bulk carrier, oil tanker, and also offshore floating unit as FPSO, FSO, and FSU. In the next slide, I will give you a better idea of those large volumes. The next point concerns the type of inspection. Today, drones have proved their effectiveness in terms of video quality and usability to perform general inspection and close-up survey. The last point regarding the close-up survey is very important. Indeed, the highest definition is as follows. The close-up survey is a survey where the detail of structure components are within the close visual inspection range of the surveyor, so normally within reach of hand. Thus, the drone and its camera must be able to show the structural details such as the surveyor would like to see. The surveyor has to be able to see through the screen the same things with the same level of details. And the last time is to address the question when we can use a drone to assist the surveyor. We have identified benefit to use drone in the framework of what we call intermediate and renewal surveys. Indeed, those surveys must include examination and check of the internal structure as specified in our rules to verify that the vessel is in compliance with applicable rules requirements. However, in some cases, annual survey may be subject to specific internal examination of the hull depending on the type, age, size, and condition of the vessel. So, Vincent, let's now have a look more in detail on ship specificity. Here, you have additional details about what we have to inspect. The drawing on the right part of the slide shows the complexity of the tank and all the structural elements that may be inspected. There are numerous connections subject to potential defect or to subject to particular attention. They can appear mainly in all areas with structural discontinuity, like connection between the longitudinal bulkhead and the bulkhead stringer, at bracket connection, and so on. On the left of this slide, there are some figures about the main dimension of the tank for ship. I mentioned before, for example, here an ESP ship. If we take at the main characteristic of an oil tanker, here it's what we call a VLCC, we have the following figures. Length of the ship is over 300 meters, with a breadth of 60 meters and a depth around 30 meters. The cargo region has around 17 cargo oil tanks and 12 ballast tanks. And and the main dimension for cargo tanks are around 50 meters by 22 meters by 30 meter height, for a total volume of 33,000 cubic meters. The next slide, Vincent, will give you an overview of this environment. So I would like to show you two flights we have performed recently in two different environments. One in a water ballast tank and another one in a cargo hull tank. Those flights have been done using an Helios 2. And just before starting the first video, let me inform you, here the quality of the video has been degraded in order to be included in this presentation. The normal quality of the video made with drones should be in 4K. So Vincent, you can start the first video. So it shows a flight made in a water ballast tank. So you can see the return flight from the central line of the ship to the exit on the deck. You can appreciate the usability and its capability to fly in complex structure. And an important thing is the surveyor must be able to access all the area he wants to see. And therefore, the light configuration of the drone may be important in order to be able to see the condition of the structure, including all the deformation or defects. The second video, you can start it, Vincent, show a flight makes in a large cargo tank. You can see the potential of the drone to access to the structure at height and to fly over the tank easily and quickly compared to a surveyor who requires specific means of access. Over those two videos, the main limitation we have identified is the flight time. It's around 10 minutes, but it's not important because to perform the full inspection, several flights are necessary using multiple batteries. Basically, a survey process consists in several flights, one for the pilot with the objective of recognizing the structure, another one to perform the survey following surveyor instruction for general and close-up survey. So here you can appreciate that the flight is very easily and very fast compared to a flight with a surveyor, and you can go close to all the structural detail here. Some connection between the transversal bulkhead and the stiffener on decks. Vincent, the next slide will give you an overview of the scope of hull periodical survey. The scope of the inspection is clearly defined in our rules. As you can see, these rules are available on our website. And here you will find an extract of the scope of work of a renewal survey and a non-exhaustive list of the important items that need to be inspected. The close-up survey is to be focused on the general condition of those items and on the different connection between all items. Another important point to be addressed is about ultrasonic thickness measurement. They may be demanded by the surveyor and are also required by the ESP code. That's why simultaneously, someone should be able to take those measurements if needed, and he has to be qualified to take it. Now let's consider the main point of interest during a survey. What kind of degradation can be found during a survey? Here, you have some example of degradation, which can be found during a survey. The two first ones on the left are related to the plate condition. During the lifetime of the unit, the steel plate is subject to gradual destruction due to the environment. Thus, the coating condition has to be evaluated, and the steel may be subject also to degradation without coating protection. If there is a corrosion degradation, it has to be evaluated and monitored. Different forms of corrosion exist, such as pitting, general corrosion, edge corrosion, galvanic corrosion, and so on. Other degradation may be observed and are subject to particular attention. For example, cracks can be found in the structure due to fatigue cycle. Also, damage and deformation of the structure can be observed. It is important to note that for crack detection, for example, if the structure is not perfectly clean, the detection may be difficult, especially with a drone. Deformation in the structure needs also particular attention due to the distortion of the image. It can be removed in post-treatment stage. However, during the survey, by using the lateral light of the drones and a specific angle, such deformation can be identified. From my point of view, there is some improvement that can be done with the length of the camera and the live streaming post-treatment. In addition, in the near future, we believe that the artificial intelligence technology may be in drone system in order to assist in the plate condition assessment and to find all this potential defect. So it was a quick overview of our use case. I will let the floor to Vincent. He will show how to do it with BV if you are a ship owner, a shipyard, or a drone operator.
Thank you, Damien. So yes, let's be practical. How to do it? Imagine you are a ship owner or a ship repair yard and you need an inspection on board the ship. Simple, you can go to our website. You will see an application there called Approval Explorer, where you will be able to localize, to search all the service suppliers offering drone inspections. And if you are operating drones, if you are a pilot yourself, are you able tomorrow to offer inspection by drone to ship owners? Actually, you need to get a recognition from Bureau Veritas to offer those services on the ships classed by Bureau Veritas. It's not. It is to verify that you are familiar enough with the marine environment, that you have the quality procedure. For that, what are the requirements? So you will find on our website the rules. They are public. It is they are the NR 533 called Bureau Veritas requirement for remote inspection techniques. So it means to get the first certificate, an audit of your quality procedure. It's an office audit. Then we conduct a demonstration on board to assess your familiarization with the environment, with our point of interest, with our use cases. And after that, you got recognized, and regularly during periodic audit, we maintain this certification. So once you have the certificate, you are listed in Approval Explorer, and ship owners, shipyards can see you, and they will get your contacts, and they can call you directly to request your services. To get recognized by Bureau Veritas, you can contact the closest BV local office. So also from our website, you will see our directory, and you can easily contact and get all the details to proceed. That's the end of my presentation. Thank you for listening.
Thank you so very much, Vincent. We really appreciate both you and Damien. Give me just one moment as I pull up my screen. Here we go. Okay, perfect. So before we dive into the Q&A, I just wanted to let everyone know that we've been doing lots of webinars over the last several months. We started in March with a series of webinars that really took the place of a conference that we had scheduled for March that was going to be in Denver at the location of our first US office. Of course, plans changed due to the pandemic. We had to cancel the in-person conference, but we turned all of the keynotes into webinars. So what you see on the screen are webinars that we've already conducted. These are all available on demand. So if you see any topics that might be of interest, please feel free to peruse these. We have all of these listed on our website. And you can find them by going to flyability.com and going to events and webinars. And then you'll see all of our past webinars listed on demand, so you can watch recordings. This one will be available, of course, on there starting tomorrow. So yeah, just wanted to let everyone know that we have all of this great content out there in case you're interested. We've had a lot of questions about intrinsic safety, whether the Helios 2 is intrinsically safe, whether drones are intrinsically safe. The short answer is that we are unaware of any drones that are intrinsically safe, but we did a whole webinar on intrinsic safety and risk mitigation last week. You can find that webinar also on demand on our website. So we're going to get into the Q&A now. One thing I want to mention, if you are interested in the Helios 2 in ways that you might be able to use the Helios 2, either because you work at Bureau Veritas and you're attending, or you work in some other organization, please feel free to contact us. Matthew, whose contact information is listed here, he is available to take questions, so feel free to write down his email, reach out to him. He'd love to hear from you, so please don't be shy. Please feel free to be in touch. And that's Matthew right there. Hey Matthew, how you doing? Oh, you're on mute maybe? I'm not sure.
All good, thanks.
Okay, cool. So yeah, if you are with Bureau Veritas, you want to learn more about using the Helios 2 in your work, or if you're with another organization, please reach out to Matthew with any questions that you might have. Thanks so much, Matthew, for hopping in. Cool. I think now we're going to move on to the Q&A. Matthew, I may tap you at some point during the Q&A. We had a question or two about the Helios 2 that I think might be best suited for you. So I think for now, it's really going to be questions for Vincent and Damien, but I'll let you know. I think we might have a few questions a little later for you, if that's okay. Okay, cool. So let's go ahead and dive into questions. We had so many questions, Vincent and Damien, from the audience. It's clear people are really interested, really excited about the work you're doing. So I'm going to ask a few audience questions. Let's start with, this is sort of a practical question. David is asking, can drones be used in tanks with the pilot flying the drone BVLOS beyond the visual line of sight? And we had a similar question from Antonio. Antonio asked, I wonder if there's a way that drones can fly a predetermined path rather than using a person flying manually. The two different questions, but related to maybe autonomous flying BVLOS. I think they're interconnected. So I'm wondering if one of you could speak to those two flight scenarios.
Yes, I will take it. You're right. Many people are interested in autonomous flight. We have to be honest. For Marine and Offshore, it is still not the most relevant use case, because during all the surveys, people are still on board. The surveyor is still on board. When we mention autonomous flight, it means that, first of all, it is more for offshore units that could be subject to condition monitoring for the hull and predictive maintenance, which is not something possible today for ships, not for technical reasons, but for statutory and for rules reasons. But it means that the owner of the assets will invest into the drone and will have the drone on board who will run the autonomous flight. Why not? Let's see in the future. I think there are there's an interest for that, but to be practical today, it is not the most relevant use case. Today, the most relevant use case are still pilots operating the drones from the deck. It's already a lot of benefits compared to the situation, let's say, even a few months ago.
Excellent. Okay. Thank you, Vincent. Given how much interest there was in intrinsic safety, I wanted to ask, and this question came from half a dozen people, if you could speak to ATEX. So I guess the question is, what are the issues and solutions regarding hazardous areas and as related to ATEX? So is there an ATEX drone, and how do you mitigate risk in those kinds of scenarios?
I can take the question. Indeed, there is no ATEX drones today. Either the tank has to be gas-free, and a safety and risk assessment has to be conducted to provide mitigation measure in case of ATEX zone. But yeah, today there is no ATEX drones, so some assessment has to be performed before entering this kind of tank.
Thanks, Damien. And a related question, we're wondering if Bureau Veritas certifies drones?
Indeed not, as Vincent mentioned. We recognize some service suppliers to authorize them to perform survey, to perform survey. So there is an audit, and we don't certify drones as tools. We only certify the society which is provide the service.
Got it. Thank you.
Yes, but let's add that based on voluntary basis, our colleagues are also delivering equipment certification services. So if the client interested, he can indeed apply to get his drone certified, but it is not a must-have, and it is definitely not a requirement for operating on marine and offshore units.
Okay.
We are more focusing on the operator than on the equipment.
That makes sense. Yeah, thank you both. We have a question from Marshall in the audience who's asking, does Bureau Veritas use in-house drone pilots to assist the surveyor, or do you hire out a third party to fly drones?
I will take it. In marine and offshore today, not yet, but we are working on it, and this will probably come very soon. For other markets, such as the industrial plants, we have Bureau Veritas employees operating drones.
Got it.
Including the Helios 2.
And yeah, Vincent, if you or Damien could talk about your drone program. So I'm just wondering, how have you approached this new means of inspection? If you could speak about how you've built out your drone program, the training that you provide, the documentation, safety guidelines, things like that. If you could talk about building your internal drone program a little bit, I think that would be helpful.
I can take it, yes. Indeed, we have performed some, at the beginning, some tests in order to see if this technology is reliable or not. And then the second step was to perform some POC. So we have compared a real survey with the result we have with the drones. And then we recently have performed some what we call pilot. The pilot is a survey where we are crediting the inspection using drones. So it's the last step. And in parallel, we have published some technical reports, and we will publish soon technical guidelines to reflect the implement during real survey and the outcome of this development.
Got it. Thank you. We have a sort of a practical question from David in the audience who's asking, what size of access is required to get into a tank for an inspection? Yeah, how much space do you need to have the LEOS-2 enter?
I think you should imagine that traditionally a ship is inspected by human. So wherever the human can go, the drone has to go. And the size of the drone we are using are consequently smaller than human. But it can go, let's say, the openings can, for the smallest one, it's 400 by 400.
That's really helpful. We have a question. We had several people ask about this, but Manish in the audience asked, what would you do if the drone got stuck because the battery died prematurely? And then we have David asking, can you use a tether? We had other people asking about tether. So can you speak to that concern that you might lose a drone inside a tank and, whether you use tethers or not?
If I can, today these drones are not ours. So we hope later to operate that model, but today they are not ours. So it's more a question for the operator of the drone. But indeed, practically speaking, let's say if we take as an assumption that the battery is for 10 minutes, usually the operator, he got some alarms a few minutes before, and he knows the time to come back. And usually it is not only one flight. We run several flights. It is well prepared. So first it's a recognition flight. We don't take too much risk. Then we go deeper and deeper. And we always keep enough battery to come back. But that happened, that could happen that the drone is left inside the tank, but it's not, I mean, it's not dramatic. I mean, just keep in mind that usually we should be able to go anywhere to inspect everything physically. So this means that we will send someone on inside to recover the drone.
Sure. Yeah. That makes sense.
If I may add, most of the time, safety and a safety plan is prepared in order to avoid any situation like you described with the loss of the drone or something like that. So it should be assessed before the inspection.
Thank you, Damien, and thanks for the extra info on that. We have a question about, well, we've had several questions about thickness measurement and using robotic solutions for measuring thickness. Can you speak to how you currently measure thickness and whether you foresee using the LEOS-2 or other technology for thickness measuring in the future?
Indeed, the thickness measurement is a very good question, because as I mentioned, in the what we call the ESP code for oil tanker and bulk carrier, the thickness measurement should be taken in the same time as the visual inspection. So we have to do that. Today is done with what we call a normal way with rope access, or we have seen some crawler to do that. Yes, I don't know what to add, Vincent, if you want to complete.
Yes, sure. I mean, it's possible, and this already happened. Some drones are taking UTM. It's already existing, but it is not today. I have to say that the techno we have seen is not as performant to be fully industrialized. So there's a lot of development, but in this, while waiting the techno to reach the objective, there are many alternatives. You see, we can use poles, we can use crawlers, we can use other techniques. And what I want to say here is that the solution may not be today immediately everything done by the drone. We have to be realistic. The solution could be a combination of several techniques, such as fold, crawler, as I mentioned, laser camera, many things today. And this is already done. We have credited surveys by drones, including the UTM. So it's a reality.
Interesting. Yeah, thank you. Speaking of maybe future technologies or future solutions, can you speak about where you see things headed with the use of drones and robotics in marine inspections? What do you think will happen over the next 5 years, and what do you think would be the ideal future scenario?
I think there are two main potential to be explored, and the people are working on it intensively. I am forcing a lot of improvement thanks to artificial intelligence that can be embarked on board the drone, that will really help to for a better quality of the outcome, for a better quality of the record, also helping for a better assessment and better condition monitoring of the asset, which is a prerequisite, which is the enabler to deploy a more predictive maintenance that have actually a lot of potential in terms of optimization of the maintenance, cost saving, better quality, etc. So this is one area. Second one is also the power of the 3D modeling. Drone is also, I would say, one enabler to generate rebuilt 3D model. It's very easy. For a long time in marine and offshore industry, 3D was exclusively CADs, FEM calculation, etc. People are more and more turning to the 3D modeling based on rebuilt model, thanks to 3D scanning, photogrammetry, etc. So I do see also a great future there that will really transform the way we cooperate, the way we work, the way we visualize, the way we exchange the information, the way we share the information, the way we anticipate, etc.
Great, thank you. We have had questions, Vincent, about 3D modeling. We had one question, let's see, from Karthik, who asked whether it's possible to create 3D models in real time. Can you speak to that?
I haven't seen yet.
Yeah, maybe one day.
I'm dreaming of it.
Yeah.
I know that people are working on it. I have seen some concept. It was not with aero drone. It was with underwater ROVs, where it was, let's say, almost autonomous ROVs that is able to rebuild the environment and to navigate like that. So it's really a real-time modeling, but it is still at experimental stage. It is not something that could be industrialized today. But yes, technology is going very fast, and why not tomorrow? Sure.
Right. It could. I mean, I think the next, I won't say 5 years. I think the next 1 to 2 years, we're going to see a lot of breakthroughs and a lot of things that might have seemed far away 5 years ago. So yeah, we're moving pretty fast. Question about regulations. Given that you're flying indoors, we have Marshall who's asking, are there local regulatory considerations, permits, things like that that you need to take into account when conducting these indoor inspections with drones?
Indeed, there is no authorization need required for indoor inspection compared to outdoor inspection. For outdoor inspection, you need to have a license and also to have authorization from aerial authorities. The chance we have with indoor inspection is that we we don't require any authorization to flight, any license, so it's more or less easier than in terms of authorization than flying outside.
Yes, and let me add that our use case is mainly indoor, so no need to worry about that. We have a lot to do together, and so this is not an obstacle today. But even
the only thing is that as we are working in a marine and offshore industry, the service suppliers, so the drone operator needs to have a knowledge of our environment in terms of marine structure and so on, in order to be able to flight through what the surveyor will ask to them.
Thank you both. We have just a sort of straightforward question from George, who's asking, when you are conducting a survey or an inspection by drone, do you need extra lighting inside of a cargo tank, or does the drone provide enough lighting by itself?
It's a very good question, because usually the preparation of one tank before the inspection, it's a lot of job. So scaffolding, staging, ventilation to get it gas-free, gas detection, also lighting. And usually during the inspection, the ship repair yards, they have to install fixed lighting. Drone carry by themselves the lights. And I have to say that I was very impressed the first time I attended a drone inspection, because I haven't seen a tank before with such good lighting.
Excellent. So no extra preparation with lighting is required. The drone gives you everything you need. Excellent. I have a question. So this is from George, a different George in the audience. And I'll be honest, I'm not sure. I think he's using language that I'm unfamiliar with, so I think you guys will know. But George's question is, can drones be used to feed information for twin applications? And it's the twin applications. I'm not sure what he's referring to, but does that sound familiar to you?
I think what George imagined is a drone who will be able to send condition monitoring data directly to a digital twin to feed him in real time. Once you have the drone, once you have the connectivity, you have the 3D model, you have the smart data linked to the 3D model, let's do it.
Okay, that makes sense. Thank you. Thanks for the education too. We have a question, let's see. Mauricio is asking, how many days do you need to perform an inspection when you use a drone? How long does it take on average?
I would say, depending on the size of the tank, but a complete campaign for a VLCC that was such as the one presented by Damien, complete campaign can take 2-3 weeks, but it's not only for tank inspection, it's combining a lot of items. What could we say? We can say today that we have measured the performance of the drone reducing by 20 to 30% the time spent during the inspection.
That's pretty significant. Have you tied that to savings to reduce the amount of time by 20 to 30%? Do you have numbers behind how much might be saved using a drone instead of using manual processes?
I would say that, okay, if you have a VLCC, such as the one we have described as an example, the cost for complete dry docking, scaffolding, etc., it's 90K 90K or more. With a drone, okay, you won't save 90K, but you can really reduce this cost by optimizing the scaffolding, the staging, only where it is required. So the big advantage of the drone is to enable the anticipation of the repair. There is nothing that we discover during the dry dock. We know everything in advance. We can better plan, better optimize the means of access.
So it helps you not need to build scaffolding just to collect visual data where repairs won't be needed.
That's it. That's the main advantage, yes.
Excellent. And so it sounds like if, let's say, a typical inspection is 90,000 and you're saving 20 to 30%, you could put a dollar amount on that as a minimum of 20,000, 20 to 30,000. Do you think that's true, or would you not want to get that concrete?
It's not that simple. It's not that simple, because when I said 30 to 50%, it was a time reduction.
Okay.
And but I mean, I would not believe. I won't believe in drone. I won't be talking to you about drone if that would not be cost effective, because any client will go there if it is not cost effective.
That makes sense.
And this, of course, I mean, it depends on the price, local price. I mean, in that country could be different, etc., etc. But I do believe that once we will have a worldwide network of local operators, that I mean, that will become a new usual model.
Yeah, and especially I think the more frequently the technology is used, the more savings you'll realize, right? The more you have people who can fly the drone and it's a common tool instead of being sort of an exotic option, but just a regular tool. The more often it's used, the more you'll save, right? Because it's a one-time expense as opposed to scaffolding being a regular expense for each inspection. I'm going to have Matthew hop on real quick just to answer a question we had about the price of the Helios 2. Hey, Matthew. So someone asked, let's see, I like their wording. They said, this is Manish. He asked, what's the cost for the Helios 2? I hope it's okay to ask. And it's definitely okay to ask. So I wanted to bring you on because you're really the expert we have on the team who can talk about the cost of the Helios 2 and answer that question.
Yes, yeah, of course, the price is public, huh? So it really depends, of course, on the options that you select and the use case that you're going to use it for. But basically, it starts around $35,000. But most of our clients, they get started with the professional package, which is a package that includes everything you really need to professionally operate the drone and to fly intensively. So you can do some repairs, you have your spare motors, batteries, and this is around $40,000 US.
Thank you so much. One other question that, Matthew, it might be for you, but also Damien and Vincent, I think all three of you can speak to this. We have Shubhankar who's asking, with drone usage comes the crucial issue of data storage, right? Drones collect a ton of data that needs to be stored, and you don't want to compromise the quality of the data when you're using it for visual inspections. You want to maintain the quality of that data so you can use it. So I'm wondering if both of you can speak, if we can hear from both sides about how data storage is dealt with. So Shubhankar was actually asking how flyability addresses data storage. So Matthew, I'll start with you, but then I'd like to hand it over to Vincent and Damien as well to hear about how Bureau Veritas deals with data storage. But Matthew, if you could address that question first.
Yes, so that this is very true that the output of the drone system is basically a video file that can be 4K or 1080p. So quickly you can generate a large amount of data, but at the end of the day, and Bureau Veritas will correct me, the reports, it's mostly pictures. So most of the clients I speak to, the inspection companies, they extract, from the videos, the pictures that make sense. And of course, we have a software for that helps you to generate reports in a very easy way. And the video usually is just archived, and it can be used to prove to the end client that the coverage, that the asset has been inspected 100%. So it's more a safety, but basically the client is never going to watch the full video files. He expects the expert to extract the right information that will lead to the right maintenance decision.
Thank you so much. And Vincent and Damien, if you could speak to how Bureau Veritas deals with data storage and data usage.
Yeah, I confirm what you said, Mathieu, but it looks a trivial question, but it's very important. I think that we all need to learn from this world becoming digital. It is generating data. Data is costly and also a source of pollution. So I think it's a new practice, new behavior that we all need to learn, not to make too much replicates, etc. To have a good practice in first generation of the data, but also storage, archiving, etc. I think we have to be honest, is that we are learning. Everybody is learning. It's new for everybody, and I do believe we will have new behavior, new good practice. It's a challenge.
Thank you very much, Vincent. So we are 2 minutes over the hour, so I think we're going to end things there. Thank you, Damien and Vincent, so very much for taking the time to share your expertise. I want to tell you that I think this is the most questions we've ever gotten in a webinar, and that fact alone reflects, I think, how hungry everyone was to hear from you and to learn more about how drones are being used in marine and offshore applications. So just thank you so very much from me and from the entire Flyability team. We really appreciate you taking the time to present today.
Thank you.
And
thank you
Matthew,
for the opportunity.
Yeah, Matthew, thanks for joining us. We're going to sign off for now, but we'll certainly be in touch. Remember, you can reach out to Vincent with questions about Bureau Veritas. His email is on the slide that's in front of you. Reach out to Matthew with questions about the Helios 2 or flyability in general, and we'll certainly be in touch. We hope this is the beginning of a conversation, not the end. Take care, everyone. Thanks for joining us today.
Thank you.
Thank you.